Hello students, this is just a small tutorial to show you how to obtain your endpoint from your titration data. So in your titration data, you should have two columns, one for the volume and one for the pH at each uh, new additional volume that you added for your titration. And if we plot these two columns together, we obtain, I usually use for titrations this either the smooth lines or the margin smooth lines. So let's just see a smooth line. So you can see in your data that whenever you have this big jump in pH at a particular volume, that should be your endpoint. The thing is that it is very difficult to get that information from these plots. So we need to do some data treatment to this raw experimental data in order to obtain the most accurate endpoints of the titration. And for this purpose, we need to obtain the first and then the second derivative. So to obtain the first derivative, we should have first a column which we should call the average volume. And we need to average values between these pairs of volumes. And we do that because we need to smooth down your curve in order to better approximate your first and second derivative. So we will have to obtain average of the volume and then average of the average for the second derivative. So let's go through that. So you begin in the second cell instead of the first cell, and you add a formula which is equal average, and we just select these two volumes, the first and the second volume, and that should give us the average between these two values. Then we can double click on the corner or just drag down to obtain the average between any two pair of volumes. For example, in the last one is these two pairs, and here is between these two pairs. Okay, so far so good. Now we need to obtain the first derivative. Let's call this first derivative. And the first derivative is nothing more than the slope at any particular volume and pH. So the slope, the formula for slope is it's the difference between y values, let's say y2 minus y1, close parentheses, and the difference between the x values, x2 minus x1. So that's just the formula for slope, or the derivative formula, let's call it like that. So we go to the second cell, which is not empty, and we do equal to, open parentheses. In this case, our y values are the pHs, so it's second pH minus first pH, close parentheses, divided by, open parentheses, second volume, which is the x value, or x2 in this formula, minus the first x1 value, close parentheses, and enter. And this is the first derivative, and we can just drag down to obtain the slope at each particular pH and volume. And if we plot these two columns together, the average volumes and the first derivatives, we get a very interesting plot. So if we look at the original plot, we see that right where we have an inflection point, we have a maximum in the slope or a maximum in the rate of change of pH as you add more volume. So that makes a lot of sense. And we need to define which volume is this maximum point. And it's better to obtain the second derivative because the second derivative is more precise than obtaining the maximum here. So for that, let's do an average of volumes again, just to smooth down the data. Average volume, but in this case is the average of the average. So let's call it average volume 2. Go to the third cell now, instead of the second, equal to average. And you do the average of the first two average volume values. A little bit but tongue twister there. And we get this value. And again, just drag down to obtain all the average of the average volumes. And then we do, again, this formula for the slope, which is equal to the difference in y values, so open parentheses. Now the y values are the first derivative value. So this y2 minus y1, close parentheses, divided by x2, open parentheses, x2 minus x1. We close parentheses, enter. And then we double click or drag down, and we have the values for the second derivative. Then we can just select these two columns and insert chart and smooth line. And now we see that the second derivative at the endpoint of the iteration should go through 0. So it's an intercept with the x-axis. And this plot is like very telling, but we need the actual value. So to calculate the actual value, we cannot get it from the plot, but we can calculate it with a function of Excel, which is called intercept. So we can see that the endpoint is around 20 milliliters, which should be around here. And you can see that the second derivative goes from a very positive value to a very negative value, which is this large value here. And then the next one is a very low value, negative value. So your endpoint should be between these two volumes, which are very close. Well, we can even approximate it even further with more precision. So to get the intercept, we type in intercept, open parentheses, and this function gives you the y values for the intercept, but we are interested in the x values because we are measuring volumes, not pH. So in order to properly use this formula, we need to change the y for the x. So let's type in the x values first. And in this case, the x values are the volumes. So just select these two, which are where the second derivatives changes from positive to negative, comma, and then instead of the x values, we select the y values, which are the corresponding positive and negative second derivative values, and close parentheses. Enter, and you get the volume, which corresponds to your endpoint of that titration. And remember to always use only the appropriate significant figures according to your uncertainties from the burette. So be very careful of that. And also remember, when you show your plots, to show a proper title and with the appropriate axis styles and everything else that I already taught you before. So thank you for watching.